Alright, so we have a 3D MATLAB model of wing aerodynamics. The one in the NASA was not that good, so I decided to make one on MATLAB. So we have flaps at 0 degrees and spoilers retracted. So you can see here, if I was to maybe change the angle, or let's see if I can show you. So you'll see here in a moment that there is a flap. So this is a flap here, and the green thing you saw was the spoiler. All right, so this blue thing is the flap. You can see it. So right now the airspeed is 50 at 50, and we have our CL predetermined coefficient of lift, coefficient of drag, lift to drag ratio, the lift, the flap, and the spoiler. You can see it at 0%. So now let's increase the spoilers from down to up. So now they're deployed. You can see that the velocity field lines are also changing. So maybe let's increase the scale of the arrows so you can see better. You can see that there was a significant change here. So for example, if I was to zoom in here, so you can see if I was to, for example, go back here, you'll see that slowly but surely you can see that the velocity is changing as per the spoiler. So the spoiler now is at up, so you can see here now it's at up, and the velocity behind it is low, right? So this would have been done better on a CFD program, but because of just the animation part, we just wanted to show, so we opted for a MATLAB thing. All right, so you can see here, if I make the spoilers to the max, you get CL is 0.1, and then our CD is 0.6. So when you have spoilers up, what happens is your lift to drag ratio decreases, right? As opposed to, for example, let's go to 0.5. Now it's 7.5. Now if you go all the way down, you can see that the lift to drag ratio is the max, which is 25, right? Now let's compare the flaps for a second. So right now the flaps are 0. Now let's increase the flaps to, let's say, 5 degrees. So you will see now on this side. So let me see if I can show you here. So you will have this part here. Let me see if I can see it. Yeah, there we go. Okay. So let's see here. There we go. Okay. So there are 5 degrees, and you can see the lift to drag ratio is increasing. They're increasing, and if we go 100, the maximum it can, this is the most it can be, right? So this is the max lift to drag ratio you're getting while the spoilers are retracted. Now, let's increase for example, the spoilers. Now it's counteracting the flaps. So that's key to note here. And then we also have, let's increase the airspeed for a second. So this shows that their airspeed is increasing. So that also changes. What doesn't change the metrics here, just show that the velocity field lines are increasing. Let's look at the streamlines for a second. So I tried to model the streamlines as well. So for example, let's change it with the spoilers, and you can see with the spoilers the streamline underneath. So for example, let's go to 0. You can see the streamline on the arrow on top of the wing, pretty flat, and then from there, if you were to increase the spoilers, it drastically decreases the flow after it. So there's like a wake pattern going on here, right? So there's streamline, and there's also a pressure field. This pressure field isn't as accurate because obviously I think ANSYS would be better, but this is something that we did come across. So you can see this is a negative pressure and times 10 to the power PA, and then this is positive pressure, and so forth. So yeah, that's it from me, and